Okay, so this I will not have taught by the time your mock comes, and there's not too much on it. So I'm just going to explain the basic idea. If I was to have your head and give you a choice, I can put a nice flat 50 newtons on your head, or I can use a very sharp pointy thing with 50 newtons. You're going to pick the flat thing because you've got a chance of surviving. 50 newtons with a small surface area is going to drive it through your head. So the basic idea is Professional Footballers Association. So PF8, the pressure is the force divided by the area. Be really careful when talking about pressure. So they'll say, how does increase in the area? And students will write, it spreads out the pressure. It's the force, it spreads out the force. So there's the basic ideas in terms of that's contact pressure. Now, the other basic idea is if I've got a surface of, say, some water, and if I was to take your head, your dead head, and put it deeper into the water, as it goes deeper and deeper and deeper, it will have more pressure. Now, fortunately for you, there's not too much on fluid pressure on this mock, and I thought I'd give you a heads up because it's definitely not your fault that it won't have been taught. So your fluid pressure is whatever depth you put them at. So I'm going to say, let's imagine, call this H, multiplied by the density of the liquid, multiplied by gravity. All right. So a way to picture this is if I really wanted to squash your head into a small bit, move it really deep, so increase the height, change the water to syrup because it's got more density, and move this all to Saturn, and then I can nicely squish your head by placing it under this syrupy goo. But there's not a lot of that on there. You've got a little bit on atmospheric pressure, which I'm going to teach now. But I'm going to leave that there. Please make sure you are happy with PFA. And make sure you know that the force is always 90 degrees to the surface. So diagram shows an object submerged in water. Label the force arrows on each of the force objects. So you can see what it's trying to make sure you know is I've got to make sure each of these are 90 degrees to the surface or as close to. Done. Next one. An upwards force of 600 millinewtons divided by 1,000 is milli. 1.9 newtons per centimetre squared for the pressure. What's the total surface area? So PFA. We see A equals F over P. I'll just put it in. So A equals F divided by P. A equals the force, 0.6 newtons. I've done that unit change from milli to newtons, divided by the 1.8. And then for me to get the area, it's whatever's left over from there. If you're to cancel your units, you'll find you'll be left with centimetre squared. Done. Next one, we've got another PFA one. So PFA. A knife exerts a pressure of 6.2 times 10 to the 9 pascals. A pascal is just newtons per metre squared. All right, they're the same thing. On an apple, the total area is 0.6 times 10 to the minus 7. What's the force acting? Well, we can see F equals P times A. So F equals P times A. That number times that number gives me 372 newtons. Done. Next one. Draw air particles to show how they're changing the column of air above the surface. So we can see clouds are up here. And the basic idea is there is more pressure. There's a bigger weight of particles as I go further down this column. So I'm just going to draw some air particles there and less up there and an intermediate amount there. Done. I just got this idea. There is more pressure here. Okay, what is atmospheric pressure? So it's 101 kilopascals, and explain how it changes with increasing height. So you've got a number to remember, 101,000 pascals. If you don't like that, 101 kilopascals or 101 kilonewtons per metre squared, but let's go with that. If you wanted to show off, 101,325, but you'd be quite happy with 101,000. So you've got to learn that number. And explain how it changes with increasing height. Well, we've just said there's more particles here, and there's a bigger weight of particles above as I'm lower down. So as I go up in height, the pressure decreases. So as height increases, pressure decreases as there are less particles, and therefore there are less collisions with your body. That's it, done.